class, welcome back to the week 13 material, and in this segment we're going to explore one of two options that we can use to get access or get more information about our NetCDF file to the point where we can actually start analyzing it. There are two ways that we can attack this. One is to use the command line, but it's also possible to get this information using a Python program, and we'll look at both of those strategies. And this first segment, first of the two, we'll actually look at how to get this information from a command line, which is a little bit faster of an approach. Running on a Python program is a bit more involved, but it is a command line. So if you don't feel comfortable using the command line, then I can understand why you might choose the Python approach. But we'll go ahead and get back onto the server to get started with it, and then go back and find our NetCDF file. And there it is. And we're going to introduce a couple of commands which will allow us to get more information about the NetCDF file itself. And one such command that we can employ on the server is the NCdump command. And the reason why it's called NCdump is because it's going to quote unquote dump a lot of information to the screen, as it's referred to. NCdump space -h. This -h is, you don't necessarily have to include that, but if you don't want to get a whole bunch of information to the screen, this -h basically is a command line argument or value that tells the command line we don't want everything, we want only the most important information. And then from there, we simply type out the name of the NetCDF file that we had before. So again, I just typed the first few letters and then hit tab to fill that in. And again, I'm going to go ahead and reiterate this to hopefully avoid confusion. This is in fact a capital O here, not a 0. If you mistype this, you're going to get error messages. If you mistype the file name, you're going to get error messages. So if you were to run that command right now, you would see something that looks like this, which is a fair amount of information, but it's not so much so we can't process what's going on. So I'm just going to go ahead and start at the top here and work our way down just to sort of illustrate what's going on here. So this right here basically explains what the dimensionality of our data set is. So in this current data set, there's 180 grid points along the longitude. So there's 180 values of longitude. There's 170 values of latitude. And in this case, we have 24 entries of time. So this is basically, you can sort of think of this as a 24 by 170 by 180 data set. So you have 24 possible time values, you have 170 possible latitude values, and you have 180 possible longitude values, which if you do all the math of that, that's a lot of data. There's no question about that. This specific NetCDF file is actually on the lower end of NetCDF data. It's only a couple megabytes. I remember working with NetCDF files as part of an internship where the individual files themselves are actually several gigabytes because it was data for a year, and you had an entry for each day, and the latitude and longitude values were a much higher grid resolution. I think they were 3 kilometers, so there was a lot more data to sift through. But you can encounter NetCDF files that are quite massive, but the format is essentially the same. You have a value for the number of longitude values, a number of latitude values. Sometimes you can also have NetCDF files that have a vertical coordinate. So an example for that might be if you're looking at pressure as it varies vertically. If you're looking at a pressure data set, then you might have a vertical coordinate. But most of the NetCDF files that you'll have will be 3-dimensional. That is, you'll have a time dimension, a latitude dimension, and a longitude dimension. And then contained within that are the names of the variables contained within the NetCDF file. And this will probably be more significant once we actually look at this in a little bit greater depth. But contained within the NetCDF file is a variable called lon, which in fact stores a list of longitude values. And one thing that I do want to draw your attention to is the units shown on this line right here. So the units for when you see the numerical values contained within longitude, those numerical values are in units of degrees east, or how many degrees east of which basically boils down to how many degrees of longitude you are east of the prime meridian. So I believe that's 0 degrees east. So yeah, you go 1 over, that's 1 degree east. You go 2 to the east again, that's 3 degrees east. So that's how it's stored. Now you might be wondering what happens when you get to say 181. What is that? That's actually 179 degrees west. So at that point you cross the international date line, in which case you're in the Western Hemisphere. And in fact, as we'll see later on, the highest value in the longitude is 359 degrees east, which you can translate that to 1 degree west. And then scrolling down, there's another value in here called lat, There is technically another variable called lawn bounds, but we don't actually need to worry about that. But there is another variable called lat, and that in fact stores a list of latitudes that are contained within the data file. And the units for this are in degrees north. This is set up a little bit different from the longitude because the longitude folds back on itself as you travel around the world. That is not the case for latitude, so the value convention is a little bit different. And by convention, if you see a negative latitude value, you are in fact in the southern hemisphere. So if your latitude value was negative 34.5, that is in fact 34.5 degrees south. Whereas if it was just positive 34.5, that would be 34.5 degrees north. And that's what we have in the latitude variable. And the time variable, which is given by just a lowercase time. And the units for this are days since January 1st, 2001. And as we'll see once we actually look at the data, the data actually steps up by values of 30. So if you're stepping up by values of 30 days, you're actually going from 1 month to the next. So even though the units for this are technically days, because the days are spaced, because the time variable steps up by 30 days, you can actually think of this as a unit of months instead of days. But generally, most of the data that's contained within the NetCDF file, usually the time unit is in fact days, whether it's taking a sample of 12 days out of the year or 365 days out of the year. And then finally, this variable called TOS, that is in fact the variable that's storing all of our sea surface temperature values. And one thing to note right away is the units for that are in Kelvin. So just something to keep in mind as you're going forward. If you pull a number out of the sea surface temperature value, then you're going to get a value that's in Kelvin. So if you're wondering, so if you get a value of 275, that is in fact in Kelvin. If that was in Celsius or Fahrenheit, then I would be very worried about what's going on in our oceans. But fortunately, the way the units work out, that 275 is in fact in Kelvin. And that's pretty much the gist of it. You just need to mainly look at how many longitude, latitude, and time variables you have, and also to see what those variables are actually called. Now, if I want to, I can actually go, using the command line again, I can actually see what the actual values of these variables are. So what actual values of longitude, latitude, and time are contained within the NetCDF file. And that again uses the NCdump command, but it's going to be set up a little bit different. So I'm going to say NCdump space -v, lowercase v, lawn, I want our lawn variable, and then the NetCDF file. So I'm going to go ahead and point out this lawn right here that I have highlighted on the screen does in fact correspond to this up here, this lawn up here. And one other thing I should probably mention about the sea surface temperature variables, all of these other variables, the lawn, lat, and time, those are in fact one-dimensional arrays. This sea surface temperature value, that is in fact a three-dimensional array, and we'll talk more about that later on during the course of this week. But running this command right now will show me all the values that are stored inside of the longitude array, or the longitude list. And you can see we get this result here. So it starts at 1, 3, 5. Keep in mind all these numbers are in degrees east, so this would be 1 degree east, 3 degrees east, 5 degrees east, 7 degrees east, and then towards the tail end of that, 359 degrees east, which is really 1 degree west, and 357 degrees east, which is really 3 degrees west. And then I can repeat the same command again, except for the lat variable. So instead of lawn here, I'll put lat, which again, this corresponds to this up here, what I just highlighted. And when I run that, see it prints out a whole bunch of latitudes. And again, this is in degrees north. And by convention, negative values are in the southern hemisphere. So negative 79.5, that is in fact 79.5 degrees south. Negative 77.5, that is in fact 77.5 degrees south. And then towards the tail end of that, we have 88.5, that's 88.5 north. And 46.5, that is 46.5 north. And then if I want to look at all the time values that are stored in here, and I just simply type in that variable, and you can see it prints out all the values for time. So remember, the units for this are days since January 1st, 2001. So 15 is 15 days since January 1st, 2001, which is right in the middle of January. 45 days since January 1st, 2001 is in fact right in the middle of February if you work that out on a calendar. And then 75 days since January 2001 is in fact the middle of March 2001 if you work that out on the calendar. And if you go to the tail end of that, you can also work this out 705 days since January 1st, 2001. That in fact puts you in the middle of December of 2002. So again, even though these units are technically in days, you can sort of think of these individual time entries as what month you are in the data set, starting with January 1st, 2001, which would be entry number 0 if we're using traditional human nomenclature on how arrays works. And the other thing that we can do, although I do not recommend trying this, if we want to see every single entry of the sea surface temperature values, so remember this grid, it's 180 by 170 by 24, which if you multiply all that out, you'll get something like 30-something thousand data points. So if you want to see 30,000 different numbers being 30-something thousand different numbers being shown up onto the screen, then you are certainly welcome to run this command, but I'll just show you what happens if you try to run this command to say, give me every single sea surface temperature value entry in the data set. Yeah, I don't recommend running that command on your end unless you want to see all these numbers. If you want to sort through 30-something thousand different numbers here, yeah, that's I think we found some numbers here. But yeah, this goes on for a while. So wouldn't recommend dumping all the sea surface temperature values to the screen, but you can absolutely do this for the longitude, latitude, and time values. And in the next segment, we'll explore how to get this information using a Python program. So with that, I will see you guys in the next segment.